Hello and welcome to another Big Data London webinar. Today I'm joined by Paddypower Betfair and they're going to talk a little bit more about what they're doing in real time. So I'm Andy Steed, Content Director at Big Data London, and I'm joined today by Raresh from Paddypower Betfair. Hello Raresh.
Hi Andy.
And Alex from Betfair down there. Hi Alex. Quickly before we get started, these sessions are designed to be interactive, so please do ask as many questions as you like using the question box at the bottom of your screen there. Quick note on housekeeping. I realise the pressure on everyone's internet's quite high at the moment, so if you do lose the stream at any point, if you just refresh in your browser, you should jump straight back in, just in case for people who've got kids on Fortnite or Teams or whatever they're supposed to be doing at the moment if they're actually doing their home learning. So without further ado, I would like to throw you over to our first presenter today. Over to you, Alex. Thank you.
Thank you. Let me share my presentation. It's okay. Okay. Hi, everybody, and welcome to this session. My name is Objelean, and I'm a principal developer at Paddypower Betfair. Our company, we are working we are based in Cluj-Napoca, Romania, a lovely city in the heart of Transylvania. But let me first start with a few words about us as a company. Paddypower Betfair is a part of the Flutter Entertainment Group. We are a global sports, betting, gaming, and entertainment provider. Our mission is to bring entertainment to life for our customers in a safe, responsible, and ultimately sustainable way. In the past 6 years, we've been a part of the team building a system from scratch and turning it into a world-class platform for operating promotions. One of the goals of the platforms was to bring the personalization and real-time customer experience to a whole new level for over 7 million active customers. Achieving this was challenging, considering the massive load we have to deal with, especially during popular sport events. Just to give you an idea, a single product called Betfair Exchange generates more transactions than all the European stock exchanges combined. Today, the platform powers 3 brands, Paddypower, Betfair, and FanDuel, and we are extending it to other brands in the group as well. Most ideas presented today are influenced from the experience we gained while building this platform, and we hope that you'll find it interesting and useful. Okay, how would you describe a large majority of customers today? You could use words like impatient, in a hurry, with short attention spans, with a desire to experience pleasure or fulfillment without delay. Designing an application which provides a real-time experience can lead to a better customer acquisition and retention rates, improve customer satisfaction, thus increasing the chance of success of your business. So how does a real-time application design look like? Well, any success story starts as a monolith, also known as a monolithic architecture, meaning that we put all the functions of an application into a single archive package to deploy and run. Usually, this kind of application uses a single database to store all the business-related data. Achieving real-time in this type of application is easy, given any interaction with the system is synchronous. Any customer action is reflected immediately in the underlying database, and the system can return the updated result, taking into consideration previous customer actions. But as the application evolves and matures, and the number of features grows, so does the size of the code base and the number of teams involved in the development. Still, monolithic code bases do not scale to a large number of users, and crucially, a large number of developers. Operating in many markets with unique requirements, someday will need many teams, each working on different areas of the product. So these teams will need to control their own development, deployment, and scale without having to coordinate their changes with other teams. In short, the development process needs to be distributed and decoupled, just like our software. Okay, now let's assume that we want to break the monolith. The first attempt could lead to microservices deployments communicating through a shared database. And this becomes extremely inconvenient in the sense that the shared schema of that database tends to lock the versioning of the services. If you change one thing that involves schema change, you'll have to change every other service relying on that schema. It can lead to situations when you have to sync the releases or maybe do them in particular order. So even if the services are separated, you cannot independently evolve and version them. Okay, the next milestone in the evolution of the architecture is having services that don't share database. There are two types of communication patterns between services in this kind of architecture. The first one is through synchronous API calls using some kind of RPC mechanism like REST that allows easier to independently version services and doesn't have this locking through a shared schema. But it creates greater problems like service discovery and the failure cascades. The second communication pattern between microservices is asynchronous communication. It is called also reactive or event-driven. So instead of point-to-point communication, it allows you to multicast messages to various services at the same time. Well, the primary benefit of this communication pattern is the evolvability of your architecture and ability to create new services or update existing ones easily. The technology behind this type of communication is usually a message broker. In our organization, Kafka is the technology of choice. And currently in production environment, we have several clusters with hundreds of topics through which billions of messages are flowing on a daily basis. Well, zooming out, the system we are working on might end up looking something like this. Of course, keeping the system real-time is a challenge in itself. And in case of event-driven communication, it boils down to making the consumers of events as fast as possible in order to cope with the overwhelming amount of data flowing through the system. Now, let's get back to the real-time aspect. How can we measure it for a complex system using asynchronous communication based on message queues? We can use an interesting analogy with the shopping checkout at a supermarket. Each customer staying in the queue is like an event. Using this analogy helps to understand what exactly real-time is. In a perfect scenario, the customer doesn't have to wait in the queue, and his perception of real-time is great. However, during peak hours, the shopping experience degrades significantly because of the time spent waiting in the queue. One possible way to measure real time is by the size of the queue. Consumer lag is an indicator of how much lag there is between producers and consumers. And by observing the lag, we can be alerted when a certain threshold is exceeded. This might indicate a potential problem. However, this metric can be misleading because it doesn't take into account the time factor. In other words, even if the shopping queue is long, it doesn't necessarily mean that you'll spend a lot waiting in the queue. The opposite is also true. Short queue doesn't necessarily mean that the waiting time will be short as well. A better metric to measure the real-time perception is the maximum time spent by a customer in the queue. This metric gives you the worst-case perception. Now, imagine a simple situation. Then there is a queue in the supermarket with 10 customers. If on average customer is served in 1 minute, the last customer will have to wait about 10 minutes. But any delay or a problem, like an issue with POS while serving a single customer, can increase the waiting time of the rest of the customers from the queue. Of course, processing an event in a complex system doesn't take a minute. Most of the time, it takes maybe milliseconds. However, the same reasoning applies here. Any problem during consumption, like downstream errors like database outage or network glitches, leads to a degraded throughput and increased waiting time. So next question is, what can we do to minimize waiting time? Keeping the shopping checkout analogy, the easiest solution is to increase the number of cashiers. This is equivalent to increasing the number of partitions for a topic. However, this approach has its limitation. Like first one is that it can cause uneven distribution of load, or the second one is that it has physical limitation. in a supermarket, as a supermarket has finite space and cannot have more cashiers than the space can allow, the same applies to partitioning. So this limitation does not allow leveraging the entire processing power, assuming the application cluster has a large number of nodes in order to cope with a massive load. To overcome this limitation, we adopted a hybrid approach that involves a database of our choice, Couchbase NoSQL. So how does this hybrid solution works? By measuring the waiting time of an event, when a certain threshold is passed, instead of continue processing event, it is persisted to Couchbase, which is used as a virtual topic with unlimited number of partitions for delayed processing. This is like transferring customers from a cashier's to a self-checkout station opened on demand, thus bringing down the worst-case perception of the time spent in the queue. You might ask, but why not always process all the events this way? Well, the reason is that it comes with some costs, like increased network traffic, and also it has some fixed time delay due to indexing of newly added events to the storage. By using a hybrid approach, we managed to achieve the following. First, a great real-time perception during non-peak hours, and it's usually less than 1 second. And the second is that we can leverage the entire cluster processing power during peak traffic. Anytime a delay of a threshold is detected, the secondary processing mechanism is activated. Thus, all the nodes of the service are participating in handling the load by keeping the real-time perception in a reasonable duration. Well, why Couchbase? Why we have chosen this technology? Well, because it has built-in support for the following key features. Like it is distributed, it is scalable, fast, and easy. And the most important feature in context of our problem is the performance. Here you can see a couple of metrics from our production system. The first one on the top is showing the number of operations per second observed during replication of data between 2 data centers. And you can see that we observed over 1 million transactions per second. The second metric from the bottom is showing the throughput we achieved by a single VM during some intensive workload. And you can see that it consistently takes over 10,000 transactions per second while communicating with Couchbase. These numbers are quite impressive and provide enough confidence in order to build a large-scale system link with mass. Well, here is another example from production showing the hybrid approach in action. In this scenario, there was a massive spike of events that caused an increasing lag in processing. The hybrid consumption mechanism activated by transferring a large part of events to Couchbase in order to leverage the processing of the entire cluster. This helped the system to cope with the processing of over 500,000 of events in about 3 minutes. Not having this mechanism in place would lead to a recovery that would take much longer. There are various scenarios when this situation can happen. For instance, the system needs to recover from a temporary failure, which leads to accumulation of a large number of events to be processed. Or another scenario is that there is a spot event that triggers a reward for hundreds of thousands of customers who are opted into a promotion. Well, to sum up, the key takeaways from my presentation are that the real-time aspect is crucial for designing a successful application because it can lead to improved customer satisfaction, acquisition, and retention. Designing a complex real-time application is challenging, but using the right technologies can help. In our case, the combination of Kafka messaging and Couchbase NoSQL technology fits very well. By designing the secondary processing mechanism that is enabled anytime there is a degraded perception of real time, we managed to cope with the massive spikes and reduce the number of complaints from customers during the sport events. And I would like to end my part of presentation with this quote from Gall's law, which states that a complex system that works is invariably found to have evolved from a simple system that worked. I will run you the the presentation. Thank you, and waiting for your question at the end. Just a second.
Thanks very much there, Alex. So before I just pass over to Raresh for the second half of this presentation, anyone who may have missed the beginning of the presentation, or indeed wants to go over some of those images again, this presentation will be available on demand almost instantly after we finish. So you can go back, rewind, fast forward, pause, whatever you need to do to get to that information again. But however, here we go, and I'm going to pass over to Raresh to finish off. Okay, thank you.
Thanks, Andy. Thanks, Alex. I will pick it up from here. So our promotional system, as Alex mentioned, it's designed in a modular way, and this has proven to be essential because it has allowed us to incorporate ever more variations of the mechanics that we support. And I will go over some of these mechanics, which are all very different to each other in the experience they offer to our customers. But they are all modeled on the same system and use the same concepts in our internal systems. So take this example. It's a pinball game. It looks like a pinball game, so the user is expected to press the button to launch the ball, and the ball would land on one of the prizes at the bottom. So we've evolved this from a classic interaction in a promotion system where a user would do something, and they would receive a reward at the end of their action. So that was a classic interaction. So we've been able to easily evolve that by just packaging together more rewards and treating this as a new reward that would come bundled. And the user again would do something. In this case, just press a button to launch the ball, and then the new reward would just extract, randomly or based on some kind of distribution, would extract one of these rewards and offer that to the customer. Of course, you can also get nothing. So not necessarily every spin is a winner. But this has been this has allowed us to offer a very different experience to what a usual promotion is, while modeling it on the same system. Another example would be the Loyalties Promotion, where we have designed, we have modeled this as a ladder. So there are various tiers, from an entry-level tier, such as you've done a £1 bet on our systems, to higher tiers. We've done £10 bet. So the way this works is, say a user does makes a bet with us. We progress the user into the first tier. And say the user does another bet, £10 bet this time, we progress the user into both tiers. Again, the flexibility of the modeling has allowed us to have a single promotion that would give the highest reward at the end. So in this case, if you have completed all the 3 tiers, we would pick the highest tier at the end, which is the £10 tier. A very different interaction, again, has proved to be something similar to lotteries, where normally the user would interact again with our systems, and the reward would usually be something that could be spent online. But this time, we've given the user a ticket. So just it's not a physical ticket; it's a virtual ticket. But the actual fulfillment of that ticket doesn't happen in our system. It happens externally. So broadcasted on TV. So the user would watch like an online draw where maybe his ticket would be extracted. So these are all very different, very different interactions for users, and we have been able to model them on the same platform, just by having the flexibility offered by the NoSQL JSON schema that Couchbase provides us. Something else that I'd like to cover now is in terms of monitoring. Couchbase comes with very nice and detailed dashboards that allow us to have great insights into what is currently happening on the system. So this is an example of a production dashboard that allows us to see various metrics. Now we have to integrate this into our own monitoring of production systems, which looks something like this. We have the ability to go back in time, so to pick the interval that we are interested in, and also various metrics, and correlate those between all our systems. So we had to extract this kind of information from Couchbase and feed it into our systems. So I'm just going to show you now how what this involved. We've done a bit of scripting. So we have added some custom scripts on top of Couchbase, and these scripts are just making sure the statistics are periodically delivered into our OpenTSDB, which is our time series database that keeps data points from all our production systems. And whenever we are required to do some kind of investigation, we use this visual tool called Grafana. This one just pulls data out of TSDB, of the database, and plots the actual dashboards that I've just shown previously. So based on this integration between Couchbase and OpenTSDB, we've been able to have the same data into our production monitoring system, and correlate the Couchbase metrics with metrics from other systems, so that we detect problems and various correlations between the behaviors that we've seen on our systems. Very related to this, we've also integrated an alerting mechanism. Again, Couchbase has some very powerful stats displayed on this on the dashboards that report things like if errors had happened, or if something is paused or not working. This particular screen is showing the state of the replication between data centers. We operate 2 data centers. We have 2 clusters, so we need to replicate data from one cluster to the other. So while this is very useful in real time, what we wanted and needed is a way to actually have an alerting on top of this. So for this, we use a tool called Sensu for our for alerting in case problems happen on our production systems. So again, by developing a custom script on Sensu, we are checking the REST endpoints that Couchbase makes available for us, and we're checking, for example, the state of this replication. And as long as the state is fine, so it's running, no errors, no pauses happen, everything is fine. But as soon as something happens, errors or the state of the replication changes, notifications are fired. So this could be like email notifications for things that are not so severe, or if we are experiencing some service degradations, we just phone or send SMS alerts directly to our development teams. So this has been very helpful for us, and the fact that Couchbase exposed this kind of REST endpoints for controlling and getting information about the state of the system, this has been very, very helpful for us. So moving on, this would be the last topic. We have a dual data center topology, which means we have applications deployed in 2 data centers, and both of these data centers are taking live traffic from our users. So request could be routed either to one or to the other data center. This depends on various criteria. Usually we operate in a 50-50 manner. So half of the requests go to one data center, the other half go to the other data center. One of the problems that we had to come to have a solution for was that if the application writes locally into the local data center, we could run into some problems when we operate a request or a message for the same user ID, because the same kind of document could be modified to have, say, value A in one data center and value B in the other data center, which would cause some kind of conflict when replicating. So to overcome this, we've taken the decision to actually not write in this active-active manner. So have the applications from one data center divert the traffic to the other data center. So we call this well, active passive, because one data center takes all the writes. So this one has become the active data center. The other data center just takes data that is replicated. So it's a passive data center. It's on standby, so it's ready for us to switch and to move the traffic from the one that is currently active to the one that is passive. So this has been very flexible. We have used this active passive switch a lot of times, even for maintenance reasons. These are very predictable when we just want to evacuate traffic from one data center. But we have used it in a lot of other scenarios. And the fact that replication has been, as Alex has shown, has been very powerful. It has a very good throughput, has enabled us to keep this data in real time in sync between the 2 data centers. So to wrap up, I'd like to just emphasize a bit the important aspect. So the fact that we had an adaptable core platform has allowed us to model a variation of representations for our customers. So things that look very differently are modeled on the same system, and this has been a great asset for our business to evolve into exposing new kind of promotions and new kind of offers for the customers. Also, we treat monitoring with great care, because every software that we put into production has to have monitoring, well, detailed monitoring to understand what's actually happening with it. And when it comes to alerting, most important thing is to have something that is actionable. So alert only on things that you need to intervene. Otherwise, it should be just an email or just a Slack message. So don't alert on things that you can't fix. And last thing. It's always you have competing concerns between keeping your performance in good shape and keeping your data in integrity. So in this case, we have chosen to take a small hit on performance, because we have to move traffic from one data center to the other. But by doing this, we have guaranteed the data integrity, which in our case has been very important to sort out. So thank you for watching this. I'm going to hand over to Andy now.
Thank you very much, and thank you both of you. Actually, that was absolutely fascinating. I think people at home would have really enjoyed that. I really like the pictures, Raresh. I've not seen someone do that drawing as they go, so that was a really interesting touch too. So no, thank you very much, both of you, for a great presentation. And I'll try my best now to ask some of the audience questions. Do keep sending them through, so we can have a little bit of a discussion after those presentations. So in terms of challenges now, I was going to say, first one on more of a what's happening out there in the world. What's been the biggest challenge in terms of the biggest single sporting event or betting event that you've had to deal with in the last in the last few years? Is it horse racing or Olympics or President Trump, or what's caused the most amount of issues for you over the last couple of years? I'll stick that through to you, Alex, I guess. Sorry, yeah, I should probably.
Yeah, well, the most important event we and challenging for us happens actually every year, the same period. It's Cheltenham Grand National, and because this is the moment when there are hundreds of thousands of customers active in the same time. So this is the moment when we deal with the massive spikes that our system has to cope with. But besides those events, of course, there are other events that happens, like Champions League finals, Donald Trump US election, and also we have some sort of promotions that happen on periodical that are recurrent, like every week. All the customers that have performed some kind of action do get something at a certain point of time, and this kind of promotions leads to a situation when we have to deal with even millions of transactions, actually millions of events that needs to be processed in a short amount of time. So it's actually happens very often, and from week to another we notice an increased pattern in volume of transaction, and it's a challenge for us actually every time to cope with this increase of traffic.
And to take on from Alex's point, everybody wants their money in their accounts instantly, if possible. So this is very interesting, because by optimizing one system, such as this promotional platform, we have pushed the load and the strain on our internal systems, so the downstream systems. So things like what we call the fund system, so basically the system that take care of your wallets and amounts. If we have 100,000 users, for example, waiting for money to be delivered into their account, and you optimize this delivery system, then you're just pressing or pushing the fund system, in this case, to actually cope with this load. So what we ended up is balancing. So we could go even faster, but we need to make sure other systems are in good shape, so not press them to the limit. Yeah, this has been an interesting journey, because you can't just optimize for performance into one place and then degrade or cause chaos in other areas of the system, because eventually you're not going to solve the problem for your customer.
Yeah, no, absolutely. And I'm going to ask this question. You may have just answered it, but it's quite interestingly worded. So, what's the most challenging architecture modification you've had to carry out? In the last few years or last 12 months, if you like. Would it be what you were describing then, or has there been another hill that you've had to get over, which has been tougher?
I might start with saying that I find the fact that we needed to support 2 data centers at some point of time after the merge between Paddypower and Betfair. So we started developing this system only for Betfair. And as you know, organization changes, and there was a merge, and any merge requires some sort of changes that are not only organizational, but also from architecture point of view. So our challenge was to support the same system, but for different brands, and also have multiple data centers. And sometimes we had to deal with situation when both data centers needed to be active at the same time. Also, as Raj described, there are situations when we have to divert traffic from one data center to another. So there are a lot of problems we needed to deal with and find a solution which is not very, doesn't have some out-of-the-box implementation. So it needs some kind of custom approach, because it's very, very unusual and requires different implementation.
Yes, of course. I've forgotten about the merger. That always comes with a lot of fun, doesn't it, in terms of different myriad of systems. I was going to ask you a question now about the team, your team, without going into sort of personalities and etc. How's your setup there? Because obviously, you know, there's a lot of processes going on. You talked about monitoring, and so how are you structured roughly? Are you in one big team? Are there little sort of little units of teams for each little responsibility, or yeah?
So we have development teams that take care, full cycle. So development, they put the code into production, and they also support the production system. We also have some small teams that are dedicated, some like DevOps teams that help with organizational or various SRE tasks around that. And it's been interesting. We started building the system with 2 teams mostly. And over the years, because of the fact that it has been designed modularly, it has grown into just hooking other existing parts of the system. So integrating with existing systems such as payments, funds, notifications. So all the other systems that we use in relation to our customers have now been adapted and put on this platform. So now we have, I think, more and more requests to just adapt the system so that it works with other software components that we use in the company.
Yeah, I would like to add that our system starts to look like an open source in some ways, because there are hundreds of contributors from various teams and thousands of pull requests, and this is quite challenging because this kind of complexity needs to be somehow handled. This is the most challenging part from dealing with such this kind of system.
Yeah. Well, somebody's written in Liverpool or Spurs, which I think is a Paddypower reference. But we were talking before, and you're both supporters of Cluj. That's right, isn't it? So any Man United fans out there might have nightmares of Champions League's past, I think, or Champions League presence, to be honest.
Well, funny enough, both Alex and I were traveling, and we've been actually at the Man United game.
I bet you had a lovely evening that evening. I'm going to end with a question about the Couchbase, and in terms of the importance of Couchbase in terms of delivering what we were talking about here. What would you miss? What would you miss if it was taken away out of this sort of thing? What's the key thing that it's done for you in terms of speed, reliability, that kind of thing? If you don't mind, I'll go with you, Alex, first.
Yeah, I think the flexibility of the schema, the fact that you are not tied to this some sort of schema which does not provide you enough flexibility to evolve the system, because as you saw in the Rarish presentation, there are tens of types of promotion which we support, and this kind of features are added on the weekly basis. So it's almost impossible to keep the schema rigid while adding features on top of it. So it must be flexible. And because Couchbase is NoSQL and doesn't force you to have some kind of model, you can model it in any way. So you have complete control over this. Also, another thing is in context of our dual data center topology, the cross data center replication feature is crucial for us, because without this kind of performance, we wouldn't be able to deliver this kind of system.
And I think it has so Couchbase came at precisely the time when we were shifting, modifying our systems from traditional request response type of interactions to stream-like interactions, where systems just publish their activity, and we observe the activity and take decisions. And this has been really well. You were asking before about architectural changes, so this has been a great architectural change inside our organization, because it has enabled us to go close to real time and to do this at scale, to do this for all users, to do this instantly, and to inspect and consume the activity from a wide variety of internal systems. So Couchbase has been well, instrumental into getting us here.
Also, I would like to add that Couchbase becomes a technology of choice, replacing various other technologies that do not perform as well, and we find the new and new use cases as we go that are in different areas of the product, not only in the promotional system.
Perfect. Well, I'd like to thank you both for a brilliant pair of presentations. Really enjoyed it. It was great to go so in depth with what you're doing over there. And I didn't mention it before, but actually we welcomed Alex and Raresh last time we did a physical event in 2019, and they presented at the London Olympia. So I very much hope to see you again someday when we're allowed. When we're all allowed to do physical conferences again. So yeah, it's been great catching up today though. And from everyone at Big Data London, thank you very much. Thank you, you two, and thank you, the audience. I hope you've enjoyed it. And goodbye. Thank you. All right.
Thank you. Cheers.
Thank you very much. Bye bye.
Thank you. Goodbye.